Hi, in this video, we'll see how to interface dht22 sensor with Raspberry Pi, Pico and picoW. This video is applicable equally to both Raspberry Pi as well as picoW, and you can change it interchangeably. But for the sake of this video and for the whole series of learning Raspberry Pi, Pico and IoT, we are using picoW mode, which has the wireless interface. So let's get started with this video. Now, dht22 is one of the sensors of the DHT series, which is a digital temperature and humidity sensor. Now, when I say digital temperature and humidity sensor, it simply means that the same sensor can give the values of temperature as well as humidity, and we don't need an analog to digital converter. It doesn't generate an analog signal. Instead, it generates a digital signal on a single line, which can be read by a host microcontroller. Now, let's get started to understand a bit more about dht22. dht22 is the advanced one as compared to dht11 sensor, which you will find commonly in market. Both of them are easily available to procure. And this is a very ideal choice when you want to measure the temperature of atmosphere, at the same time humidity as well. Useful for many home automation situations. I wouldn't recommend using dht22 in an industrial environment because the sensing element is exposed and the dust particles which can contain metal and lot many different oxides in industrial environment can damage it. But for home automation or for farm automation or any kind of indoor operations or even outdoor operations where there is no industrial dust, dht22 is useful. Now, we'll just take a quick look at the datasheet of this sensor to understand it better. This is the datasheet of dht22. The sensor looks like this, which has got 4 pins. One of the pins is supply, one of the pin is ground, one of the pin is data, and the fourth one is essentially not connected or NC or not used. The third pin in this case. Now, this is the interesting table for us. So, the power supply for dht22 is from 3.3 to 6 volts and the overall accuracy that it gives is quite good. So, 0.1 percentage for relative humidity and 0.1 degrees Celsius. The measurement range is minus 40 to 80 degrees Celsius, which is suitable for all kind of atmospheric and indoor-outdoor temperature measurements. Now, how do we interface this sensor with Raspberry Pi Pico? Let's see. For MicroPython usage, it already has a built-in DHT library. So we don't have to worry much about what are the different codes or what are the different libraries we are going to need or install. It's already there. So for this experiment, we are going to need a Raspberry Pi Pico, dht22, breadboard, jumper wires, and to this data line, that is pin number 2, we need to connect a pull-up resistor. Let's see how that is. Now, if you see this diagram over here, you can connect the first pin of dht22 to 3.3 volt, last one or pin number 4 to ground. Looking from the front side of the sensor, the leftmost pin is VCC, the rightmost pin is ground. Pin number 2 is data out and pin number 3 is NC. The data out can go to any pin of microcontroller. In this case here, I am connecting it to GP0. So if it is connected to GP0, you just have to modify your code to reflect or read from pin number 0. This pull-up resistor is required because the sensor doesn't have an internal pull-up. And in order to reflect the logic levels properly on the data lines, it needs the external pull-up resistor. Now you can connect it to pin number 1, that is GP0, or for that matter any digital pin. There is no such restriction, there is no such rule. The code to read the temperature and humidity from the sensor is very simple. In this code, we are going to use the DHT, that is the library, import DHT, and then you initialize the DHT library with an object. Let's call here it sensor. So sensor is equal to dht22. 22 is the specification or the type of the sensor we are using, and here we mention to which pin we are connected. In our infinite loop or while true loop, we are measuring the value of sensor using this sensor.measure function. Then the temperature can be extracted as sensor.temperature. Humidity can be extracted as hum is equal to sensor.humidity. and then the values are printed. I have done some formatting, but we'll see. Even if we don't do formatting, that is also fine. I'll turn on my camera now and I'll show you the kind of sensor which I have with me. So what I have with me is a module. So this is the temperature and humidity sensor module. Now if you see, I'm not using a standalone sensor. Instead, it's a module. Now the difference between standalone sensor and module is nothing, but it's just mounted on a PCB and given to us for use. The biggest difference that you may seek is the module is giving only 3 pins: data, VCC and ground. If you look closely over here, which is difficult to focus, then you will see that the resistor or the pull-up resistor is already connected on this PCB. So we don't need to connect external pull-up resistor. But if you don't have a module version and if you have the bare bone sensor which was shown in that presentation, then you may need to use a pull-up resistor. Now I have to make sure I follow the pinout diagram shown on this breakout. So the topmost one is data, middle one is VCC and the leftmost one is ground. This purple pin for me is ground. I'll connect it over here. Then the middle one is VCC, which is this pin for me. I'll connect it over here. And I'll simply connect it to GP0 data line. Easy to find, pin number 1 of Raspberry Pi Pico. And this pin goes over here. That's all. Now what I'll do is, I will first try to pick or put only this much of code. I don't want you to get confused between from time import sleep. So I'll just import time and make it easy for you to understand whenever we get a time delay or whenever we insert a time delay. So I'll just insert a delay of 2 seconds and then I'll print temp over here, only temperature to begin with. Now let me save this code to Raspberry Pi Pico as main.py, the usual practice. Now once it's saved, I can run the script and I can see the output. Now if you notice, you can see 28.3, 27.7 and so on, the temperature values are being printed or displayed onto the screen. In the same way, you can go on and print humidity value as well. Now to print the humidity value, instead of temp, I can simply write HUM or the name of the humidity variable. We have read the humidity. And now let's run the script. And this is now giving humidity in terms of percentages. You need to let at least 2-3 readings go before it gets stabilized. So if you see first one was 66.2 and then it stabilized to 75.43. That is the humidity here. Now if I just blow some air into it, try to dry it out, okay, you will see the humidity value simply decreases. Plain dry air, if you blow through it, it will decrease the level of humidity it is sensing for some time. And instead, if you give a humid things through your mouth, like it's supposed to increase the humidity level drastically. If you see now 95.7, 99.9 and so on. Now it will again take some time for it to reduce. Now let's just format it a bit well. Print temperature is curly bracket 0 and humidity is curly bracket 1. Dot format temp comma hum. Now let me stop this code and write the next one. As you can see, the humidity is now reducing and it will slowly go down to 0 or some value close to that. I again have my soldering iron here. I'll just keep it close to the sensor. I don't want to touch it because it has a plastic body. So I'll not touch it. I'll just keep it close. Let me run the code again. And I just want to see if it changes the atmosphere around the sensor so as to give hot value. If you have a hot air gun, it's good or quick to experiment with the temperature rise, but you can still sense the temperature has risen to 28, 29 something. See, I'm not touching it, okay? I am just moving my hot soldering iron close to it. Now you can just convert the same code as a temperature controller. If temperature value goes a particular value, turn on a relay, LED, fan, whatever you want to. Same thing you can do when temperature goes below a particular value. Let's say if it's less than 20 degree or 15 degree or 10 degree, then you may want to turn on a heater or something like that. For this video, the important thing was to experiment with the DHT sensor and to understand the code associated with it. Hope you will be finding it easier to experiment with your sensor. Now I put aside my soldering iron, so you can see my temperature is reducing slowly. If you use a sensor like DS18B20, which we'll see in subsequent videos, that is something which you can directly connect or touch to the soldering iron or even lit a fire on it, because it's a metallic rod that you can use like an industrial sensor. We'll see that in our next video. Thank you for watching this video.